Well, folks, this is Guruji Online, and I'm Sanjay Singh speaking from this platform. Today, we will solve question number 6 to 10 of my mock test paper dated 9th February 2020. I had uploaded on guruji-online.com this mock test paper, and you can have a look at that. So this is the sixth question. Two ice cubes 50 gram each at minus 50 degrees centigrade are dropped in 20 liter water, and water is at 25 degrees centigrade in a thermally insulated container. Find the final temperature at equilibrium. So the question is like this. This is a thermally insulated container is there, means no heat from the outside can go inside, or from inside it can go outside. So it is thermally insulated, and it has got 200 liter of water, and you have dropped 2 ice cubes which are 50 gram each, and when you drop these ice cubes, their temperature was minus 15 degree centigrade, and this water is at 25 degree centigrade. So this is the question. Now we have to find out what will be the final temperature at thermal equilibrium. So in this, water is there and ice is there. This is initially at 25 degrees centigrade, and this is initially at 15 degree centigrade. Now its temperature will go down due to the ice, means it will give out its energy, means heat energy, and due to that the temperature of ice will increase. Suppose, assume that they reach at 0 degree centigrade. Let us see what is the position at 0 degree centigrade. Basically, in this case, first ice will go from minus 15 degree centigrade to 0 degree centigrade, and it will start melting at 0 degree centigrade, and then if energy is enough, then its temperature will rise. So let us see at this milestone what happens. So what will be the heat energy due to water once its temperature changes from 25 degree to 0 degree centigrade? That is m as delta T. M is nothing but 200 liter. We can write it as kg also. Specific heat of water is 4190 joule per kg Kelvin into delta T is 25 minus, this is coming as 29,500 joule. So this is the heat energy this water will give out to ice when its temperature changes from 25 degree to 0 degree centigrade. Now let us see what is the energy ice will take. That is same formula. Here 50 gram is there, total 2 cubes are there, 100 gram is there, means 100 into 10 raised to minus 3 into, what is the specific heat of ice? That is 2220 joule per kg Kelvin, and here delta T is, it is from 15 to 0, that is 15. So this is basically coming as 3,3,3,0,0, means this much of heat energy will be utilized out of this to get this ice from minus 15 degree to 0 degree. But there is still some energy left, and that is 2950 minus, that is 17,620. Now what this energy will do? This energy will be expended first in melting this ice. But whether this energy is enough to melt 100 gram, the total 100 gram of ice, it is enough to melt total 100 gram or not, that we don't know. So let us find out, due to this energy, how much ice will melt, and that is the energy taken. Suppose it is m gram ice is melt, then it is for melting m gram of ice, this much energy will be required. That is, this is the latent heat of the ice when it converts from 0 degree ice to 0 degree water. So in M is nothing but Q upon L, or 17,620 joule upon, what is the latent heat of ice? That is 3 latent heat of melting into 10 raised to 3 joule per kg. Now this will come as, M will come as 53 gram if you solve this. Means only 53 gram could melt due to this energy. Means there is still ice is there, because we have total ice as 100 gram. That means now there is no energy left. So this has come at the thermal equilibrium, and thermal equilibrium means it has achieved only 0 degree. Suppose it has got more energy, then it would have gone from 0 degree to up. But the problem is, since not enough energy is there, so there will be still ice in the water, and water has converted to 0 degree, ice has converted to degree, whole of the ice has converted to 0 degree, and this will remain at thermal equilibrium. So final temperature is 0 degree. That is our answer. So this is how you can think of solving this kind of problems. Now we will go to the next problem. Now this is the seventh question. It says a solid cylinder with radius 3 cm and length 6 cm with emissivity 0.82 and temperature 20 degrees centigrade is suspended in an environment of 47 degrees centigrade. Find the net thermal transfer, radiation transfer rate, basically. Radiation transfer rate. Now, we know that any hot body that transfers the energy due to radiation also. And we know this formula. This is power. This is the transfer rate, radiation transfer rate is equal to sigma epsilon A T raised to 4. Here, sigma is nothing but Stefan Boltzmann constant, epsilon is emissivity it is a coefficient which varies from 0 to 1 because no body is perfect which will radiate the same amount of energy whatever is falling on it. And this transfer rate is depends on area also, area of the body, and this is T is temperature in Kelvin. So this is nothing but, what is the value of this? This is 5.67 into 10 raised to minus 8 watt per meter square Kelvin. 4. This is the unit of this constant. Emissivity we are given here 0.82. Area is nothing but, we are given a solid cylinder whose radius is 3 centimeter and length is 6 centimeter. So here the area will be pi r square plus 2 pi r l, because it is the surface area. Because this is the area through which it will radiate or receive the radiation. T in Kelvin, here T environment is given as 47 degrees centigrade plus 273 will be nothing but 320 Kelvin, and temperature of cylinder is plus 273, it is 293 Kelvin. So we can find out the P net. It is nothing but minus this is the net transfer, the radiation transfer rate between the cylinder and the environment. So if you put these values, you will get here 2.6 watt per So this is how you can solve this problem. Oh, sorry, A is also there. A you can find out from here. So now we'll go to the next problem. You must remember this formula, because sometimes the question comes, or sometimes they may ask a question like this, कि this radiation transfer rate is proportional to temperature to what order? Means it is T square or T cube or T4, like that. So you must remember this formula. So this is the formula for transfer of energy due to radiation. Transfer of energy due to conduction, we already know that is K A T1 minus T2 upon that. So this already know, and this is for radiation. So now we will go to the next question. Now this is the question number 8, and this question I have written in figures. We have been given two identical blocks, they are welded together, their area is same, length is same, and in this system number 1, this end, left end is at 0 degree and right end is 100 degree centigrade. And in this system number 1, 15 joule energy is transferred in 3 minutes. Now it says, suppose if the same identical blocks, they are welded side by side, then and left temperature is kept as 0 degree and right temperature is 100 degree centigrade, then in how many minutes this same amount of energy, that is 15 joule, will be transferred. So we know that rate of heat transfer is proportional to number 1, area, number 2, the temperature difference, and it is inversely proportional to the length. And this is how that formula H is equal to K A delta T upon L that has come, transfer of energy due to conduction. So system 1 is there, system 2 is there. So we can write it as delta H is same in both the things. Delta T1 will be equal to A is same in both the things. No, it is not same. It is basically A1 delta T upon L1. Now H1, this is H1 upon, suppose delta H1 S2 upon delta 2 will be equal to A2 upon delta T upon L2. This you can write. Here H1, these two things are same, so we can write it as delta 2 upon delta. Here A1 upon A2. Here A1 is A. Here A2 is basically 2A. That means A1, A2 is basically, A2 is increasing. A2 is nothing but 2A1. And delta T, both the differences are cancels out. And what about L1? L1 is coming like this, but here this is 2L and this is L only. That means this is decreasing. Means in comparison to this, this will be your L. L2 is nothing but L1 upon 2. So delta T2 which we have to find out will be nothing but delta T1 upon 4 or 3 minutes divided by 4.75 minutes. This is 0.75 minutes means 45 seconds. So this is how you can solve this problem. Now we will go to the ninth problem. Now this is the ninth question. This says, what is the rate of energy loss in watt per meter square through a glass window 4 mm thick if outside temperature is minus 50 degree Fahrenheit and inside temperature is plus 75 degree Fahrenheit. Thermal conductivity of the glass is 1 watt per meter Kelvin. It is given in Kelvin, it is given in Fahrenheit, so you have to see. Suppose this is your wall, and this is your glass window. The thickness of this is given as 4 mm. Thickness of the glass is 4 mm. So we have to find out what is the energy loss. Here inside, suppose this is the inside, this is inside room. Here the temperature is plus Fahrenheit. Outside temperature is minus naturally there will be energy loss like this. Now in the previous problem we have already seen that is H that is Q upon T is equal to K A, this is T1 minus T2 upon L. We are asked to find out energy loss per meter square, that is H upon A is nothing but K delta T upon L. K we are given 1 watt per meter Kelvin. Into delta T is nothing but 75 minus 15. This is Fahrenheit. We have to convert this into centigrade. Then 5 by 9. You multiply this, and now what is remaining? L. L is nothing but, here L is this, because This is the interface of transfer of heat. So L is nothing but 4 mm, that is correct. So if you calculate this, this will come as 12500 watt per square. So this solves this problem. So we will go to now last problem, that is our 10th problem. So friends, this is our question number 10 and this is the last question of this mock paper, and this is a very good question. In this question it says ice has been formed on a pond and a steady state has been reached with the air above ice above at minus 4 degrees centigrade and bottom of the pond at 4 degrees centigrade. Total depth of the pond is 1.5 meter. So this is basically the pond. This is pond. Here the bottom temperature of the water is 4 degrees centigrade. This is the total depth of the pond, but on top of it ice has formed because the outside temperature is minus 4 degrees centigrade. So we have to find out what is this thickness of ice formed. Suppose it is X, then naturally this will be now this is the meeting point of ice and water. So naturally this interface will be at 0 degree centigrade. So now since you know the transfer of heat due to conduction, the rate of transfer remains same. So we can write it as H is equal to H we know K A delta T upon L. Since transfer rate remains same, so transfer rate in this portion will be nothing but K water into area same into delta T, that is 4 minus 0 degree centigrade upon L is nothing but 1.5 X. This must be equal to the transfer rate here, and that is K ice into area is same into this is 0 minus 4 degree centigrade and L is nothing but X. So sorry, this is 1 minus X, 1.5 minus X. KW we know 0.12 into, now it will become 4, 1.5 minus X must be equal to, it is 0.4 into 4 divided by x. So if you solve this, then x will come as 1.15 meter. Let us solve this. I got doubt. Here 4 and 4 cancels out. 0.12x plus 1.5 into 0.4 x must be equal to 1.5 into 4. So this is nothing but 0.12x plus 0.6x. 0.66 x will be 0.6 divided by 0.72. Okay, this will come as 1.5 meter. So this is how you can solve this problem. You have to see where conduction is taking place, then rate of heat transfer will be same throughout the phases of the material. So this ends our mock test paper dated 9th February 2000. On the website, I have uploaded the mock test paper that is pertaining to kinetic theory of gases. So please go through the problems, and soon I will be uploading the video solutions of this. Please, if you like this videos, please do subscribe this channel, and I will come with much more and more relevant problems pertaining to your exams. So please do like the videos, do subscribe it, and bookmark my website also, so that you can be benefited from my efforts. Thank you very much.